I will now demonstrate a typical workflow using STR-validator. And in this scenario, I will analyze 85 FTA reference samples that have been directly PCR amplified using the Shure ID 27 kit. So first we open up RStudio. You start by typing in the R console window, we type library. RStudio has code completion, so when we start typing a command, a list appears with possible choices, and to select one we just hit enter. So library, and then I type the package name, STR-validator, and also the packages is in the auto-completion dictionary, so we just hit enter, and then enter again to execute the command. And now the STR-validator package has been loaded. And to open the graphical user interface, we type STR-validator without any parameters and just hit enter. The graphical user interface may open behind RStudio, so just click the icon to get it in front. Get to the Workspace tab, and then click the Import button. In this case, we have all the data in a single file, so we select File button. And then we navigate to where we have saved the data. I have it in my input files folder. Select the file and then click Open. So now we have one selected file for import, but we could also have selected a folder for multiple file import. And then if you do that, you have options for multiple files import here. And we can specify a delimiter character for the data in this drop-down menu. I have it in a tab separated format. And then there's a text box to put in the strings that represent no data. And the default is NA and an empty string. We can also auto-trim samples. For example, if you have positive or negative controls in your dataset or ladders, they can be automatically removed while you import the data. Here I only have the actual sample data, so I don't need this option. We could also auto-slim repeated columns. That means that we change the format from the multi-column format from GeneMapper to a single column format that STR-validator works with. But this data is already correctly formatted, so we don't need to check this box. A name for the dataset is suggested from the name of the data file, so I just click the import button. A good advice is to look in the R console window to check that you have imported the correct file. Especially important if you have used the multiple files import option. So we have the new data object in the workspace. And now we click import again to import reference profiles. And I use the same settings as before and just click import. So now we have two objects in the workspace, the reference sample data and the actual data. Then we click the balance tab. And in the heterozygote balance and interlocus frame, we click the calculate button. Select the dataset in the first drop-down menu. And when you do that, the kit will be automatically detected. There will be a name suggested for the result file, and also you will have a summary of the number of samples. Then select a reference dataset. And there's a button to check the subsetting, and this is especially important if you have reference samples that match multiple samples, because then it's important to check that they match with the correct samples. We have several different options here, pre-processing options to remove sex markers. The Sure ID kit does not have any sex markers, so this can be unchecked. Here we can define the heterozygous balance using different options, and in this example I want to use the smaller peak divided by the larger peak as a definition of the heterozygous balance. There's a post-processing option to calculate the average peak height for each sample. And if you have a large dataset, that calculation can be quite time-consuming. And there's actually some good use of these new columns that will be added to the result that I will show you later on. Click the Calculate button, and then the window will disappear when the calculation is finished. And you also have some information shown in the R console window. Okay, so the calculation is finished. Now we can click the plot button to plot the data. We select the Sure ID data underscore HP, and the kit will be automatically detected from the dataset. Here we have an option to override automatic titles. Usually the automatic titles are good enough, but we can provide some new names. For example, Sure ID 27 heterozygous balance, and then markers on the X title and HP on the Y title as a Y title. Here you also have an option to choose different plot themes. Well, you can exclude sex markers. We can transform the data into log. Here's options to wrap the plot in different ways. And here we can also customize the data points and axes and X labels. But these settings is good for the option to plot heterozygous balance versus the markers. So I will click this button here. And the plot, if you use RStudio, the plot will appear in the tab plots within RStudio. And if you use the R GUI, the plot will pop up in front of the STR-validator user interface. So here we have the plot. We have options to zoom the plot. So as you can see here, we have our custom title. I close this window, and then we could click the export button to save as an image directly from RStudio. We can customize the width and height and so on, and the image format. But if you run STR-validator from the R GUI and not RStudio, there is also an option here that we can save as image, and then we get a similar window as the RStudio window. So we can customize the format, the name, and size, etc. Okay, we can also save this plot as an object. STR-validator uses the ggplot for most of its plots, so that object can be exported and manipulated manually if you would like. But now I will just close the window here and go back to the STR-validator GUI. So the next thing is to calculate some summary statistics. Then we have multiple buttons to do that. Precondition with some parameters to calculate the global summary statistics. So we click the by marker button. The dataset that is selected is the latest one created. So if we did click the button directly after we calculate the heterozygous balance, the correct dataset will be automatically selected. And now it contains almost 1,800 rows of data. The target column for the summary statistics is the heterozygous balance column. And we want to group columns by marker. And we can specify the rounding to a number of decimals. I will accept the default name and click calculate. So now we can view the data, but it's also available in the workspace tab down below here. Okay, so we click the view button to view the data. And first we can look at the original data that we calculated, the complete data set. And by default, the STR-validator limit the number of rows to 100, and that is because quite large data sets will take a long time to view in this table. I will uncheck the box to look at all the data. And then I will click the view button to open the data in a more flexible format within RStudio. So now we have this data table in the viewer tab of RStudio. And we can click the zoom button. And we get a new window. I will expand that. So now we have the complete set of data, almost 1,800 rows. And then I click the proportion column header to sort the data in descending order. So now we see that the largest value is 1. And the lowest value is actually less than 1. So we can now go back to this sample and we can look at the profile and see if there is a problem. Should this profile be removed from the analysis, for example, or rerun? In this viewer, you can copy the data, you can export as a comma-separated value file, or export to Excel, open it as a PDF, or print the information. I close this viewer window and go back to the STR-validator main GUI and view the dataset. So now I want to view the summary statistic. So I select this dataset here. And I will click the view button to get it up in this RStudio viewer and zoom. Okay, so now we have the summary statistics of the heterozygous balance, and we have a total of 27 entries, one for each marker. So we can sort the table. And we see that the poorest heterozygous balance is observed in the D21 marker. And the best heterozygous balance is in the D10 marker. And now when we have done some analysis, we need to save the project. So the first time we need to click the Save As button and locate a suitable folder. I will save the project in the Input Files folder. Select folder, and then I need to type a name, perhaps STR-validator Sure ID project, and then click OK. Then we get the confirmation box that the project is saved and where it has been saved. The next time we have done something, we just need to click the Save button. And when we're finished, we can just close the main graphical user interface. And the project is saved and safe for later use. So now you know the common workflow in STR-validator. I hope you think it's useful and want to try it out yourself.